Okay, we're live now.
So you guys getting nervous for your other finals?
It's kind of getting down to that point.
Yeah.
We've only got a week worth of school left, and then next week's finals week. So
Yeah.
So how many classes you both taken?
I have 15 credits.
Credits?
So, yeah.
What do you have, Mackenzie?
I think I have 13 credits, 5 classes. They're all online.
They're all online.
Yeah.
Is this one easy or hard compared to your other online classes?
It's easy. Definitely a lot easier than the other ones, yeah.
Yeah, it's been
I think
easier than
he's
some of
done
the
it.
ones I've taken.
Don't you think he's done a pretty good? They've done a pretty good job with this one.
Yeah,
Yeah.
I do.
It's
My
pretty
other class
nice.
was,
Yeah, the structure. If online classes really have to have structure, like a kind of a routine that you do, or else it's really hard to get what's going on.
Yeah, this is the first online class I've ever taken ever, and I'm like, well, I think they did a pretty good job with it, so I was impressed. So
Yeah.
okay.
Alrighty. It looks like we have to have Gharial Crocodiles data up.
Oh, that's right.
Okay, has everybody got that up?
Yep.
Alrighty. So I guess we're gonna check the assumptions. And so in order to check most of them, you have to have a scatter plot
Right.
and a QQ plot and the residual plot. So we'll just start by making a scatter plot. Did they have a special way that you make scatter plots? I remember. Do you have to get that RES1?
That's not until
The residual.
That's
So
a
you have to do
residual
the
that
first
you do
one.
that?
Yeah.
Okay. But so you do an actual scatter plot the first time and then
Right. So
Doesn't-
head on the
doesn't-
Y and body on the X.
okay, that's what I was wondering.
And so I just like put a line on it while I'm at it.
Yeah.
You're supposed to.
It looks pretty normal. So that
Yeah.
checks the first one, right? The linear
So it's
relationship.
linear. Yep. So that one's linear.
'Cause it's a hot dog or
Right.
okay.
Then we can do a residual, right? So that's when we go into regression, linear. That's when we change. Wait.
Right. So we go regression linear and then
Save.
yeah, it's in save.
And then you go residual. On save, it's unstandardized residual.
Right. And then you just do that. You save that, or
The unstandardized one, right?
yeah.
Okay.
And then
then
you go and
And
make
then
it
you
into
go make the graph.
so dependent is head length and independent is body length? Or is it opposite?
Remind me how. Okay, I already made this yesterday, but I forgot how you make a residual. Graphs, legacy, scatter. Oh, and we put the Y. Okay.
Right. So you just change it.
Graphs, legacy, scatter, and then the Y is the residual.
Yeah, unstandardized residual, and
And
then
then X is the head.
So wait, where did you so you went linear regression, right?
Right. And then you
And
just
then-
make a normal scatter plot, but instead of on the Y having body, have the residual on the Y.
it's got that little ruler thing.
Oh, you're supposed to create the residual first. That's what I didn't do.
Yeah, you have to do the residual by.
So you go in and you create the residual by putting save, right?
Yeah.
By doing the save and unstandardized residual.
And then you put in head length for dependent.
Yes.
and then body length, and then
yeah, you put head and body normal on that one. You put,
right, and then
yeah.
it'll save it for you, and then you go back in and do it again with.
Then you go back and do the graphs with the Y as the residual.
Right, graphs, and it's a scatter plot, right?
Right.
Yeah.
Okay.
And it should show up kind of random dots everywhere, and that's good.
Unstandardized residual is your Y, and body length is still your X.
Head length.
No, head length.
Oh, head length is.
Head length is your X.
So, did you do head length for when you did your residual thing
Yeah,
for X? Okay.
I
Yeah.
think so. Yeah,
head
my
length
graph
is
looks
always-
like. Yeah, my graph looks like the one that they have. So.
Okay.
Yeah, head length is always X.
Yeah.
Because that's what we have. So.
Alrighty. So that one checks the variance.
This one checks the. Where's our little graph?
Yeah, the variance of error.
Right. And
Okay.
then the QQ plot is the next one.
And that checks to make sure that they're normally distributed.
And I just get my QQ plot by descriptive statistics, QQ. Is that how you guys get yours?
Yeah. Yeah.
And then you just put, the only thing you put in variable is the unstandardized residuals. And then, is that it?
Let me look. Yeah.
And
It
then
looks pretty normal.
it should show us a pretty normal thing. Those are all checked.
Yeah. Okay. And then the other ones we can't check. We just have to
Right.
assume that they did it correctly.
Right.
Okay. Test if the linear relationship between head length and body length, say the null and the alternative. So that's the B1 and B2 or beta 2 or beta
It's
1 and beta
HO
1.
B1 equals 0, HA B1 doesn't equal 0, right?
Right. Yeah. Beta 1 does not. Okay. But alpha equals 0.5. State the test statistic and the value of the test statistics.
So we go into analyze regression linear.
Regression, linear.
And then we have dependent as body and independent as head. And then we do statistics, and we want to get the confidence intervals and the estimates.
Statistics, confidence intervals, estimates. Estimates is already checked, right?
Yeah, it's already checked.
Okay.
I think that's all we need for this.
Okay.
So that should give us the big old chart we need.
And it gives us, yeah, a test statistic looks like.
The T is the bottom one because that's the slope, so it's the 22.675.
Yeah, 675. And that looks right. And then the p-value.
Right next to it is the 0, 0, 0.
0. Okay, so state the conclusion. That's really small, so we would
Reject.
what? Reject? Yeah, filter. Or we would, yeah, reject. You're right.
We have sufficient
Some
evidence.
sufficient
Yes,
evidence.
there is a linear.
Yeah. Right. Okay, and then what is the 95% confidence interval?
6.704 and 8.096.
Right.
So I'm confused about that because on the answer key it says that SPSS gives us what we actually got, but then how did they get the answer?
They must have calculated by hand, yeah.
Or Excel. They've been showing us how to do it on Excel
Right.
too.
Gotcha.
They probably both round differently.
Okay.
Alrighty. So we'll open up the quiz. So when you're making the QQ plot, you always use residual data for that?
Yeah, that's what you use for that. And
Okay.
if you put it on your homework or look at that chart, it tells you
Oh, it says use residual data.
QQ plot of the residuals. It says so that will remind you have that. So
Okay, I just gotta remember that.
yeah, you use residuals.
Okay, we need to open math self-efficacy data.
Okay.
Math efficacy.
Mine not opening.
Mine won't
Mine's
open
showing
either.
slow too. Mine opened. It just took forever.
Open. Oh, there mine goes too. It's taking forever.
Yep.
Okay, mine's open now. Did you get yours up, Mackenzie?
Almost. It's still trying to open.
All right. I guess we can do 3.
Yeah.
So the true line regression equation are unknown. What is the null and alternate hypothesis? Isn't that C?
Mm-hmm.
Is it always that with these, isn't it?
Yeah. That's always what we're trying to see, because as long as the slope isn't 0, then we have a linear regression. So.
Right.
Residual.
So you put number C?
Yeah, C is right.
Okay. A residual is... What's the definition of a residual?
Yeah, I don't know the definition.
Look it up real quick again. Residual is an observation. For an observation is defined by the difference between the observed value of y and the value that would be predicted by the regression line.
Oh, could be. Maybe we need to write that down somewhere
Yeah.
on our paper somewhere so that we have that, because I bet that'll come back up. Difference between observed value. Okay.
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 How do you comprehend? X is independent. Okay, a plot of residual supports using linear regression when you see a pattern in the residuals are positive. You see a megaphone shape in residuals look normally distributed with a 0 mean.
See a plot of residuals. Supports
That are
linear.
random.
Random.
Yeah, because you don't want a megaphone.
Right.
We don't want a pattern. We don't want a pot. Okay, wait a minute. Residuals we want them to solve over, right?
We want them to what?
Residuals we just want it to be all over the place, right?
Right.
So it's not you see a pattern.
Right. It's not megaphone.
It's not megaphone with a 0 mean. What does that even mean? Residuals are all positive. That, I don't know.
No, because residuals aren't always positive.
Right, so maybe it's D. Okay, if they look normally distributed, which means they look random. It's a 0.
So if there's a megaphone shape, residuals, it suggests that the variance of the error terms is not constant for all values of x.
Yeah, and then down lower it says there is no obvious pattern in the data. If linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. And so it's just saying, so what's the answer?
It's gotta be D.
D.
Yeah.
Because the other two are the other three are wrong. So.
Right, it's gotta be that. Because they look normally distributed with a 0 mean. That's the only thing that's throwing me, but.
So even the residuals are all positive, that's wrong too.
Well, yeah, because if you look at their residual graph, and most residual graphs, they're negative residuals.
Okay.
Yeah. I think it's D.
Okay.
Okay, compute the residual for math efficacy data using the software.
Okay, residuals are different. Remember what residuals are?
So they go regression, linear. We want to save these ones.
Confidence is going to be X and score is going to be Y. Right? Or is that backwards?
Okay, to do the residual, we're going to linear again? Or correlate?
Yeah, so you go to linear regression, and then you go save, and then, right?
To get the R?
Yeah.
Oh, we're getting the residual. Yeah. Oh, yeah. So that's in bivariate, isn't it?
Yeah, I think that's in correlate. I think we go analyze.
Yeah, bivariate.
Bivariate.
Right.
And we go to, am I on the right? Math efficacy. We're trying to get the residual for what again?
Score, I think. Compute using the data. Use the confidence data as an explanatory variable and as scores as the response variable.
Wait, so why are we
the
going?
The bivariates, you put both of them in, right? Let me see what you get.
I thought we were just making a residual group.
Well,
I didn't think we were actually getting R.
Don't we just go to regression?
Right, that's what I thought too. Regression, linear, and then what's the explanatory variable? What is that one again?
Or I think, or I mean,
explanatory is.
I keep getting so confused.
Is X. Explanatory is X.
Okay, explanatory is X. So, in which case, X is the independent variable, right?
Independent. X is independent.
So confidence is independent, and score is dependent.
And then save, and then unstandardized.
Yeah, save unstandardized.
Okay, so what's the question asking? Oh.
So it's asking us, after we compute, what best describes the residuals. Between negative 40 and 25, residuals that are all negative, the residuals form a linear pattern. Oh, freak, I didn't save mine. I hate when I do that.
Response variable. Okay, response variable is the Y.
Which is Y is the dependent.
The Y is the dependent. So response variable is, on this one, the response variable is
Score.
18.
I don't think they're between. Are they between negative 40 and 25? I guess they kind of are.
Yeah. Well,
Did you make a plot? Is that what you guys did?
No, we just saved them. So you know how we're making that extra column that's residuals 1 that we did earlier, so that we can make a regression graph or whatever.
Yeah. The residuals we saved.
Right. That's what we're doing.
So are you looking where it says residual statistics, and then there's minimum, maximum?
Yeah, that's what I was looking at.
Okay.
Have we ever even looked at that before?
Well, I was also just looking at the things on the graph. But I mean, when they say that the residuals are between negative 40 and 25, it's actually pretty close because it's between negative 38 and 23.
Yeah.
So I think that'd be true. And residuals, we just learned, are a comparison of the difference between the observed value of y and the predicted value.
Mhm.
So I think that the A is the right answer because they're not all negative and they don't form a linear pattern.
Okay. Did you guys already make your QQ font?
I have not.
Okay.
Are you with us, Teresa?
Kind of. I'm just confused if that's what they're really asking. Unstandardized.
Because we can make a scatter plot of residuals now and see if they form a linear relationship, I guess. You put residuals in for your y. Is that what you do?
What? Yeah.
Okay.
The QQ plot looks normal.
And I just made a scatter plot of the residuals, and they are actually they're kind of hot dog shaped. Interestingly enough, that's weird.
So, y-axis is the score.
Oh,
And-
maybe that's what I did wrong. If y is score,
Well, I'm just making sure. And then x would be an unstandardized residuals, or is it backwards?
I thought when we did the last one we put in the y-axis under unstandardized residuals,
We do.
Oh, okay.
and then in the x we put
So,
Score.
score. That's what I thought.
Okay.
So when I did that, it's actually pretty hot dog shaped.
yeah.
So, in which case, the residuals do form a linear pattern.
Yeah. And then yeah.
But they're also between negative 40 and 25.
No.
So we didn't do it right.
Hmm.
Okay, I'm trying to remember. Okay, how do you make the residual plot? You go analyze, regression, linear. No, that's a QQ plot. I'm going to go graphs, scatter, and then I put the y as the unstandardized and the x as the score.
That's what we did, yeah. Because x is your score, right? It's your response variable.
Yeah, x is the score. Okay, so the residuals are all negative. No. Form a linear pattern.
Which they appear to do.
Yeah, maybe it's C. But
yeah, I don't. It could be either A or C on this one.
Well, okay, on mine at least, for the QQ plot, there's a megaphone shape.
On the QQ.
Yeah. Well, so
okay, so to find residuals, we are looking at the QQ, right? Oh, or we can look at
Yeah, the residual plot.
There should be no pattern in the residuals.
Right.
And the scatter plot should be linear. And was the scatter plot linear, the original one?
The original scatter plot?
Yeah.
I didn't look at the original one.
Let's look at that.
So that's where we just put confidence in for y.
Yeah.
The original is hot dog shaped, yes.
I'm wondering if that's what we need to do.
I think that it's linear. It looks linear. And when I look at it, like on the... When we look at the the graph that they have in the book where they put unstandardized residual on the y and head length on the x, it was not linear at all. It was just scattered around, and ours looks like a hot dog.
What statement best describes residuals? So we're not looking at residuals when we do the first one. We're looking at regular, right? When we do the first graph.
Which one? Number 6?
Yeah. Let me see. I'm talking about number 6. Are you guys? Oh, you guys are past 6. We decided you put it was linear.
No, we're still thinking about it, but I think that it is linear.
Because okay, so when we do the first one, the first the first scatter plot that you put the confidence in the score, that looks linear, but that's not checking residuals.
No, that's not. That's just checking the scatter plot of the data.
Right, and so then when you do it again and you go in and you save it and then you do it with the other, that one looks like what?
It looks like a hot dog.
So that looks linear also?
It does look linear.
And that...
I don't know if that means linear, though. Does it mean linear if residuals look like a hot dog? You know what I mean?
Yeah, if it's linear, it looks like it's any sort of a line. That's not right. It's not supposed to look like that. But if it looks linear, then that's probably what we're looking for. We're not looking in a response variable thing. We're not...
right.
What's the response variable? With score data as the response variable as the y. Is that what we did?
Yeah, that's what we did.
Yeah, I think it's linear. I think that's right.
Yeah, if it's not, then it's between 40 and 25, but it's not exactly between 40 and 25, so. Okay, use the software to create a scatter plot. Given the scatter plot, residual plot, and QQ plot, which of the 5 assumptions? Oh, number 7, QQ plot?
Yeah.
Fairly normal? I put normal.
Yeah.
Yeah, it does look normal.
Okay, sorry.
Is it fairly normal or normal?
Fairly normal.
So C?
Well, the first one, the top one is clearly not normal.
Oh, I didn't read that. Oh, fairly normal. Okay.
Okay, so we've used we created all these scatter plot, residual plot, QQ plot. Which of the 5 assumptions about linear gradation are satisfied for the data? Okay, so there is a linear relationship between x and y because our scatter plot looks normal, right?
Right.
But
residuals aren't normally
the
distributed.
variance of error terms is constant for all x. That one's not true. And the residuals are normally distributed is
not true because it's linear.
Right.
Okay.
Right?
Well, that doesn't tell you though about the residuals.
What tells us? The QQ plot tells us about the residuals, or does the?
Oh no, the Q plot determines if the error term is normally distributed.
Oh, that's right. And then we check the residual plot, and there should be no pattern. And it seems like there was a linear pattern in the residual plot.
Right.
Right?
Yeah, right. So is residuals the error?
No, that was the residual plot shows if there's no megaphones or something, that's an error.
Yeah, that's the variance of error is constant for all the values of x. So B is not right, or I mean C is not right, but what about the residuals are normally distributed?
Well, that's what I'm saying. I think that you do that residual plot, that first one where you do the residual plot, and it looks linear.
Right.
And that means it's not right. It's supposed to be like all scattered.
Right. So what about the values of x are measured without error?
That's the one we can't check, so we assume that's true. And the observations we assume that's true.
Okay.
So we checked.
The only thing that's getting me here is because when you look at, there is a linear relationship between x and y.
That's
you check
true.
that with the scatter plot, so that's
right.
true. But then on here it says the assumption the error term E is normally distributed. You check that by the QQ plot.
And that one looked okay.
Yeah, but where is that on our answers? Is that on there? Is that the residuals are normally distributed?
Yeah, the QQ plot is points and the QQ plot are close to the line. So that residual.
So which one does
is
that
distributed.
verify?
Oh, so that must be the B.
Right, that's what I'm thinking too. Because the variances of error terms is constant for all values of x is the residual plot, not the QQ plot.
Right. So is it just C then?
Yeah. So.
Because that's
yeah.
the one that our residual plot doesn't look correct.
Right. That's what I think.
So I think it's got to be C. I think you're right. I think that the second one is checked by the QQ plot, and the QQ plot.
The Q plot was good. Right.
Yeah. I think you're
But
right. I think C is right.
So don't click C. Only click the top two because it says which ones are satisfied by the data.
So we are clicking all of them but C?
Yeah.
No.
Yeah. Because C and E are satisfied.
Right. No, because wait, I don't know what the question's asking us because I thought it was saying check the ones that the data verifies.
Which the 5 assumptions satisfied by this data. But isn't it always just say?
Yeah.
We're assuming the other ones, so.
Right. That's what I think too.
So what are you saying then? You checked everything but A and B?
No. Everything
but C.
Because the last two we assumed to be true.
Oh. I see what you're saying now.
Yeah.
Do we always just assume those to be true?
We always assume those to be true.
Yeah.
Okay.
We checked 4 out of the 5.
What I was confused is because I thought that you don't. Well, I thought you assume that they're true, but the data doesn't verify it.
No, I think that you just
Always click those.
always click those.
Okay. So what is B1, the estimation for the slope?
So go back to B1. And B1 is slope is the bottom one. So 0.470.
Where's this? Did you already run your
I
test?
think we did when we were doing all the other things. I think we ran it already, but we can run it again.
Okay, so where's this at? Is it under
Coefficients.
coefficients and then
And
confidence
then
rating?
B. Yeah, it's coefficients and then and standardized coefficients, and it's the B column. And the first is the y-inner slope and sept, and the second one down is the slope. So it would be
So you got, what did you get?
0.470.
Oh, because I've got 12.69.
That's what I have. I have 12.695.
Okay, let me run it again. So we go analyze, regression, linear. Oh, I have unstandard residuals in that one. So we're going to go confidence rating in the dependent, and score in this. All right, maybe I just ran it with the wrong one. Okay, oh, now I have a way different number. Now I have 0.042. Thanks.
Okay, so we're going, right, analyze,
Regression, linear.
regression, linear, and then score is our dependent, and our independent is confidence. And
Is that right?
above that was what we had. Because it said, assume that your explanatory variable is score, and you said explanatory is x, right?
Explanatory is x. So
And x is the independent.
is score. So x, independent is score, and confidence is.
Yeah, so I ran it wrong, it looks like.
Oh.
Yeah.
Dependent is confidence?
Yeah.
I guess so, yeah.
Oh my goodness. Okay.
Dependent is
Confidence.
y. Yeah.
And if the explanatory is.
Explanatory is independent is the x.
Oh, maybe our Q. Oh, that might have messed everything up if we had that wrong.
Yeah.
Oh.
That's the hardest part about this one, isn't it?
Yeah, I always get them mixed up. It's so hard for me to keep it
Okay, I'm gonna rerun residuals on the standard or on the scatter plot and
It
see
says
now.
confidence data as explanatory variable and the score data. So we're using the confidence as explanatory, and explanatory is X. So the confidence is in the X, and the response is the score.
So confidence is X.
And then the score is Y.
Okay, so when I ran that, that's frustrating. Let's see. That might have messed up all of our other answers too.
Okay. Score is Y. Right?
Right.
Okay.
But by Y, that's the independent or the...
Y is the dependent response.
So we had it right then.
Yeah.
We had it right then.
Okay, so it's 12.695.
So the dependent response is confidence rating,
Dependent is response is Y, yeah. And that
and
is
score is independent.
dependent score and confidence is independent. Yes.
Okay, yeah, so we had it right.
Oh.
Well, we want the confidence interval as well, it looks like.
Okay, well, I think
Actually, so I now have Y as being 0.42.
But you just switched it, right? Like you just switched it. So
Yeah.
you need to switch back again?
Wait, what do you have, Teresa, for your B1?
My B1, I have 12.695.
Oh, you have 12 now? Because now I have what you have, 0.042.
Okay, wait a minute. What are we doing? Okay, one last time. Okay.
Okay, so hey, I'm going to write this down. Explanatory variable means what?
Explanatory is the dependent.
It's the independent X.
Yeah. No, independent is Y. Right?
No, X is independent.
Oh my
X is
goodness.
independent.
X is independent?
Yeah.
No. Independent?
Yeah. Is X.
And then which is
Explanatory is score.
explanatory?
So X is independent, response is Y. So we're supposed to put explanatory as score. So explanatory is the X, which means it's the independent. So score is independent.
Okay. Y is the dependent, which is the response, which is the confidence.
Yep.
Alright. Okay. I kind of just want to start this all over. I have so much information on this thing now. Okay.
So if you run that test, we're back to it being 0.42.
Yep, we are. Boy, that's a crazy one to try to keep straight. You have to write it down and
Yeah.
really pay attention, because that's easy because
Yeah.
it changes.
Right. And so, well, here's the thing too. That messes up our residual plot that we just did too.
All right, let's just do it again.
Okay. So I have 0.042.
Yes.
Okay.
So for our x-axis is score, so it doesn't mess it up actually.
Confidence. Oh, wait a minute. The confidence data as explanatory.
So, you know, now that I look at it, so I just, yeah, we did it backwards on the residual plot. And now that I do the residual plot the way that we have it now, where x is score,
okay, no,
y
wait a minute.
is,
Okay, stop again. The question in 6 says use the confidence data as explanatory. Explanatory is X. Confidence data is X.
Well, What?
Use
Oh.
the confidence data as the explanatory variable. Confidence data, explanatory. Explanatory is independent X. So confidence data is
It's
X.
X. So we've got
And
to.
it says,
We had
and
it right the
score
first time.
data
Here,
as
dang it.
response. Score as Y.
Confidence and
As
then
X.
score as. Okay, so we did it wrong again.
I'm going to...
Oh my goodness. Okay.
Okay, so we're going to go regression, linear. So confidence data is X then, so that's the independent.
Okay, confidence is the bottom one. Independent. And then score is dependent.
Right.
And that should be the right thing. So the 12.695.
And that won't let me put it in there anymore. What the heck? Won't let me put it on there. That is ridiculous. I'm gonna have to close this and open it back up.
Yeah, I had to do that too. That had so many different things.
Yeah. Okay. So.
Math efficacy. So confidence is X, score is Y.
Okay, so you were doing that on that bottom one, right? You were doing that on the number 9. This is what answer you were getting. But again...
Okay, so now I have 12.695, and then for the confidence interval, I have for the lower 10.674, and for the higher one 14.715.
Right.
Okay.
So score is dependent and confidence interval is independent. We want a confidence and we want to save.
So
All right.
10 is A then, right?
So I have 12.695.
Yes. 10.7 and 14.8.
Oh, for number 9, right? I
Yeah.
forgot to change it.
And then 10 is that it's not quite the exact number.
Right.
Mine's
They said that it would do that.
10.674 and 14.715.
Yeah, I'd put that one.
A.
Yeah, I'd put A.
Okay.
Based on what decision do you make for hypothesis test? You're going to reject
Look at
the
our
null.
T, and the T is, yeah, reject the null because the
B.
P value is 0.
Yeah, so B on that one.
Reject the null
Okay. So
because
then
P value is less than A, so B.
Yeah. And then so that there is sufficient evidence to conclude that the slope is not 0.
Yeah.
Let's see. It says we create confidence. Say there are
Yeah, because the
0 is not in the confidence. We can say that that's not 0.
So sufficient that it's not.
So C.
Yeah.
So is this?
Okay, so for 13, the dependent is body length. Oh, why do I have this so confused? Yeah, body
The
length.
dependent is going to be.
Okay, are you on 14?
13.
Yeah.
Okay, we have to do a 99% confidence interval on this one.
Oh, really?
Yeah. So we have to run
That's
it again.
easy. That's what was 13?
I think it's body length because
Yeah, body length.
Dependent is.
because that's what you're trying to figure out because they give you head length.
Right.
Yeah.
Okay, so we have to open up that data right because
Is that what we're doing this for? Since the 90% for this data is, yeah, it looks like it.
okay.
We don't actually have to find it. We just have to say what
Okay.
it means. So since the 99% confidence interval for this data is 7.124 and 8.3, we can say what about B1? Since it does not contain 0, there is sufficient evidence that B1 is not equal to 0. There's a 99% chance confidence interval will contain the true value of B. I think it's that one.
I think it's A.
Oh, you think it's A?
Uh-huh.
Oh, I thought it was 99% confident. How come you think it's A?
Since confidence interval does not contain 0, there's sufficient to conclude.
But don't you conclude that based off of the p-value, not the confidence interval?
No. When you create a confidence interval, we say that we are X% confident that the true regression slope is between the lower and the upper limit. Since 0 is not in the confidence interval, we can say that B doesn't equal 0.
Or where were you reading that at?
I wrote it down from one of the lessons.
Oh, one of the lessons.
Mm-hmm.
These questions always get me. They confuse me. But so the first one.
Okie dokie.
A.
Interpret the confidence interval.
I think it's A, but I don't know.
Okay, it says we are 95% confident that the true slope of a regression line relating to head length and body length of Asterian crocodiles is 7.276 and 8. So we're 95% confident that the length of the head increases by 1 centimeter. That means the increase in the body length is suspected to be between 7.276 and 8.159 for 95% confidence interval.
So you're thinking it's B?
I think it's B. But I'm not sure. I mean, you very well could be right with A.
There's a 99% chance that the interval will contain the true value of B.
So it says we're not at the regression lane. That the length of the head increases. But I'm not sure, like I said. I remember, I mean, that's how we've interpreted confidence intervals for most of the semester, but you said that you found somewhere.
But for this question, it's not saying how do you interpret, like, what's the best way to interpret the confidence interval.
Right, it says what is B1 based off of this.
What can you say about B1?
Right.
So,
so it's probably B, because we...
Well, if you read somewhere that it says that B1 is not equal to 0, then, I mean, that's very well could be true.
It says since 0 is not in the confidence interval, we can say B1 is not equal to 0.
Was that in this lesson or was that last lesson?
This, I don't know. I just wrote it on my main paper, so.
Let me look at that last lesson. I'll search it real quick. Simple linear.
Yeah, it probably is B. I don't know. Dang it.
I don't know. I'm searching the other lesson for confidence interval stuff, but I'm not finding anything.
Okay.
I want to find out where, because you could be right. I just want to find out where we learned that part, because I want to read over it again. So we can all put a different one, or I don't know.
Yeah.
Or I'll put B and you guys can put A or whatever you want.
Okay. So are we pretty confident about the other answers?
Yeah, I think so.
Okay.
We'll see. This was a tough quiz, so.
Just to make sure, for number 9, we put 12.695.
Yeah.
And then for 10, we put the first one.
Yeah.
And then, okay, back on 6 and 7 and 8. That's still confusing to me.
I don't even know if we'll know.
All right, I'm gonna submit mine. Okay, I missed 1 or 2. Okay, I missed 6 and 8. The last one was A. 14.
Do what?
14 is A.
Is A.
Yeah. but 6 and 8 are wrong. But it doesn't give us the right answer.
I want to go back and do 6 and 8 because
Yeah, I do too. I think we just need to make sure we have the right data in there, and then run the test again.
Because I think I've got the right data again, so I think I'm going to try and do that one.
Okay.
So
Have you guys not submitted yours yet?
I didn't.
Mine's submitted.
Oh, okay.
So
but let's see. I messed up, but I got it right. I never actually changed my 6 to say that they don't form a residual. So I got the residuals are -40 and 25, but I missed 8.
Okay.
So why then? Dang it.
Okay, I'm gonna look though, because I think I can create the graph, because I remember I had mine mixed up on my graph, so I can figure out right now if the residuals are.
So figuring out the residual graph, you're just going to graphs QQ and putting the Y.
No, I'm actually just doing a scatter plot because the QQ was already good. We're only looking at the residual plot right now. And the X would be confidence. And when I put that in, it is not linear.
Oh, okay.
My graph is correct now. The reason it was wrong before is because I had score, and we had score as our X. And then when we redid it, it is correct. But
okay, so there's not a linear relationship?
There is not. No. It's a good graph. But I don't think 8. I think 8 is wrong because I don't think, in my personal opinion, the last 2, I don't think we can check them because the data doesn't tell us that.
So you think it's just the first 3?
I think so. I think it's just the first 3. I don't know if you want to try that, but I think that's what it is.
I haven't turned mine in. Should I try that and see if that's right?
Yeah, I'd try that because, yeah.
Okay, I'll try that. And then I left my 14 as A, so that's right?
Right.
And then the 6 is the residuals are between -40 and 25. How did we get that?
Well, you can look at your RES1 file, all the data that they've given us on the side, the new data that's over there. Mm-hmm. You can look at all of that, and it'll show you what's your biggest number and what's your lowest number if you go through it all. But you can also just look at the output menu. And the output menu has, when you graph it, it says residuals -38 and maximum is 23.4. So we knew that was true. We just thought because of the way that our graph was turning out that it was linear, but we had our graph wrong. So.
Okay, I still don't find the residual graph.
So the way that you make it is you have to go to scatterplot, and then you put your unstandardized residual, your new column, as your Y, and you keep your X the same.
Okay. So my Y is unstandardized and my X is confidence.
Right.
And then I push OK, and that should give me.
And does it look scattered?
Yeah, it's scattered.
All right.
So then how do I get the numbers?
So go up, and there's a little box that calls residual statistics. Do you see that?
No.
If you ran, go up to where your coefficients data is and your ANOVA data.
Okay, I see that.
So do you go below that and you see residual statistics?
No, it didn't run it. Do I need to click something for it to run that?
You have to save it. It should have ran it.
I have to save it before with my regression line.
Right. It should have ran it though. But.
And then my unstandardized needs to be on Y, which is dependent.
Right.
Unstandardized, dependent, and then independent is the confidence. Yeah. And then I go to save unstandardized residuals.
Right.
And then I can make
Then you can now you have that saved data. You put that saved data into your y, and you keep your x the same, and then you'll make a graph. But based off of just running that test, there should be a box that appears now that says your residual statistics, which is underneath your coefficient box.
Okay, I see it now. And now that's negative 38 to 23 or something.
Right. Yeah, that's what
And
it
that's
says.
how you got that.
Yeah, which we got originally, and I put that, but then we looked and we said that it was linear, and I forgot to change it, but I got it right anyways.
Good. Okay, so what I did is I checked the top 3 on 8, and let's see if that's right.
Yeah.
Okay, it is right. So the
Yeah.
top 3 are right.
Yeah, I figured that was true because just because the data doesn't tell you those things,
You can't
No.
you can't say it does.
you can't say that the data gave you it. You can assume it's true, but you can't say that the data specifically verified
Okay.
it.
Okay. That's fair.
Okay.
So even though we can't really check them, we can't claim that the data made it.
Right. Right.
Okay, so the ones that we struggled with were the residuals, and we figured out how to get that.
Right.
And that number 8 is because those 2 we can't assume. And then the
Right.
very last one is that it's not equal to 0.
Right. I want to figure out. I'm gonna go read through that again to figure that out.
I'm thinking where I read about that was on this lesson.
Oh, okay.
And it was where you were trying to get the confidence intervals, the true regression coefficient. So it's kind of in
Oh
that
yeah,
area.
I see that. I'll read through it again though. So.
I think that's where I wrote that down. So.
Okay.
Okay. So
Sounds good.
I'm doing the describe the data. Make inferences this week.
Yeah, make inferences.
Okay.
We can talk about it on Wednesday.
Okay. Sounds good.
So, okay. See ya.
All right. Hey, thanks, guys.
Yep.